Hello, good evening, everyone. Sudah makan? Can you hear me? That's good. Sudah makan? Belum makan? Okay, so today we will continue with lecture number 7. So this is, I believe you have studied this one in data mining. Or maybe this is just a revision for you. This is one of the most common technique used for classification. So in the last two lectures, you study about neural network and also perceptron. So today we will learn about decision tree and look at some of the terms that for benchmarking that you need to know. So the basic idea of decision tree is that they will divide your data into sub-partition depending on the value of the feature that they use to split your data. So the aim is they want to have all the sub-partition or all the groups that they have to be in the same, to have the same labels or to have the same process. So remove this. So decision tree learner build a model in the form of a tree. So for example, we have a tree below here. Some of you just came in. Okay, so for example, the decision tree shown below, we have a series of logical decision, and at the end of the tree, which is the leaf, they show you the label or the final decision making. Okay, this is about should I accept a new job? So they look at some of the criteria like if the salary is at least 50,000 and the commute hour is less than 1 hour and the office offer free fee, then I will accept the offer. Other than that, I will decline the offer. So this is one of the example that we can use as to show that in classification using decision tree, we divide the data according to the value of the attribute. But the issue that we want to address here is how did we pick the attribute and also the value of the attribute that we have in our data set in order to split our data. So two issues here. The first thing is what feature you want to use because you may have several feature, right? And then what is the values of the feature that you want to use in order to split your data into sub-partition. So if you look at this data, in this one we have types. So you can divide them using a linear line. So the first one is if x if the value of your x1 is greater than W10. So W10 here. If they are greater, then you check again if the X2 is greater than W20. Then we say that they belong to class 2, the red one. Otherwise, you will say they belong to class 1 here. So this is a very simple example on how we can split the data using the condition that we have for the value of the attribute that we have. In this example, we only have two, x1 and x2. We could have more than two. Okay, and then how do we choose whether we choose x1 first or x2 first or x1 first? Okay, so since the computation time nowadays is very fast, so normally they can check this one very fast in deciding which feature you want to use and then what are the values that you can use. Okay, so if we refer to the previous diagram for univariate where we use a single variable, okay, so we will split them according to the value that we are looking at here. If you have n-way split, which means more than 2, then you will have to discretize them. For example, your xi here can use xi here greater than 10. But if you want to have n-way split, that means you have to have a few partitions saying that xi greater than 10, and then in the middle here is your xi is in between 10. Let me erase that one because we could split them into few. So this one is if they are greater than 10, and also we could also have a partition saying that if x is less than 5, then we also have x I, which is size less, which is greater than or equal to 5 up to, and we could also have this, and which is less than 10 or equal to 10. Okay? So in this case, we have first first partition is this one, and then the second partition is this one, and the third partition is using this. So that is if we want to have n-way split, meaning that we have more than two splitting. So we need to discretize. Discretize means we divide them into partition according to the value of the features. And the leaf that we have here, this is since we are performing classification, so this leaf will indicate the label, the class label. But if we use regression, so last time we used logistic regression, so this one, the leaf should indicate the average, the standard, minimize the standard deviation between the other branches. So in trying to divide your data, they use the greedy algorithm. They find the best split recursively. So how did they do that? So basically, they will try to use all the value that you have in your features, and also all the features that you have in your dataset. They will perform all of them. So the approach that they use is divide and conquer. So where the decision tree are built using heuristic called recursive partitioning. Recursive partitioning meaning that you use the value to partition and then you perform again the sub partition that you have until you reaching the stopping condition. Okay, so the stopping condition criterion is reached and all the example the nodes have the same class. So you do not have to split them again down, split them further. Or there are no remaining feature that you can use to distinguish among example, meaning that you have to use all the values of your feature. Or you have a predefined size limit, meaning that you will only perform up to 3 or 4 levels depth of your decision tree. So that is what we call the stopping condition. And one of the requirement is that we want to have all the nodes, for example, like this. If we split them into two, we want to have all the leaf here to have the same most 100% belong to one class. So use the entropy. So entropy, I think you have studied in data mining. They are referring to purity of your partition when you divide them into sub-partition. So for example, like this, the maximum value for the entropy will be 1 when you have all your sample belong to positive. You will get 0.5 if only let me see. Your entropy value is here. Okay. So let me repeat that one. So based on this diagram, we are saying that your entropy value will be one here, meaning that you have 50-50 of positive and negative. Because when you have your data set like this and you want to check the positive or negative, okay, so it could be different percentage, but the maximum you can get is 50% and 50%. So this 50% is here, meaning that your entropy will be 1. But if you have all of these belong to positive, 100% them belong to positive, so your this is 1, so your entropy will be 0. So every time when you want to measure the entropy, we have to look at the class level that we have in that particular partition. So this is the formula that we use. Okay, so this is for 2 classes. So if you have 3 classes, meaning that you have to repeat that one 3 times. So this one is for 2 classes. So this is positive and negative. So let me show you how we can use the entropy to measure the purity of your partition. So the formula that we have here is for node M. Okay, so we have this number of instance that reach this particular node, and then for each of the this membership belong to the I class here. So we will look at the probability, okay, given the node, given the sample that you have, and then we will look at the probability of having the particular class in that partition. So for example, like this, we have this node and we have 8 number of items. So the probability of having A will be 5 over 8, and then the probability of having B will be 3 over 8. So the aim is we want to have all the member of this particular node to have the same label or the same class. So we should be able to measure how pure is your node or partition. So if a node is pure, then your the probability of having that class will be 0 or 1. So either 0, none, or 1, which is the whole thing is 0 is when you have all of them belong to the same class. 1 is when you have all of them belong to different classes. 50-50. So how do we measure the impurity using entropy? We will look at this formula. So this formula tells us that for the all the label that we have in our class up to k, we will measure the probability of having that particular class in that node. Okay, so for example, if we have two classes here, A and B, then we will have 2 here. And we apply this formula for this problem that we have. Then since we have two classes here, then we just in the value here, but we need to use the log base 2. And this is for the A. And this is for the B classes. So once we compute the log base 2 of this probability, then we will get 0.95. Okay, so meaning that when your node is not pure, or if you have a mixture of label, your probability here will be high, which is going towards 1. If all of them belong to the same class, so the entropy value will be 0. So if you look at here, the entropy will be 0 here, or 1. So 1 means 50-50 of them belong to different classes. The entropy will be 0 if you have 0 belong to a particular class or of them belong to different class. We'll show you later on another calculation. For example, like this, we have this table. This table show you whether we can pay or not, depending on the 4 independent variable that we have. So this is your label, yeah. Okay, let's suppose we choose the outlook to split our data. So when we use the value of sunny, overcast, rain, so you will split your data into these groups 1, 2, and 3. Okay, so based on these 3 groups, you can compute the entropy for each one of them. So later on we can choose for temperature, humidity, and wind. But we decide to choose the features that produce lowest entropy values. So for example, for the sunny, okay, for this one, we compute the value for the sunny and we get 0.96. So how do we get the 0.96? We have 3 nodes. and 2 yes. So we compute, we get 0.96. Then we also compute for the overcast. So the overcast, we have 4 over 4, 4 over 4. So the value will be 0. So notice that when all of the member belong to the same level, the entropy will be 0. If you have 50-50, one belong to the other class and the other one belong to another class, so your value will be 1, going towards 1 lah, something like this one. Okay, for the rain also we have similar, so they have 3 and 2. The value should be the same as this one. So that's how you compute the entropy for each of the partition. But now, how do we sum up all of them? How do we conclude? Okay, so we have we use the weightage. So the weightage is depending on the number of element in that particular partition and divide by the number of all element that you have in your data set. Okay, and this is similar to what we have used before. This is what we call the weightage. How do we use the weightage here? Weightage is used to compute what we call the info gain, how much improvement that you can prepare for the classification when you split the data into 2. So this is before splitting, this is after splitting. And I'll show you how to compute this one first. Again, I also need to show you how do we decide the weightage here. So we go back to this example. So when we have this splitting, we draw a line to divide them into 2. So this one we have a mixture of misclassification. So this one is not very informative. This one is very informative because we managed to split them into 2. Okay. And also this one, this is very informative. This is not very informative. So we call that the impurity of this one is low. The impurity of this one is high. Impurity meaning that the class membership belong to not 1 but more than 1. Okay. So the aim is we want to have this one, minimum impurity or maximum purity. Maximum purity. Okay. So we want to have that one. So we want to choose a value that can split the data into several partitions that maximize the purity or minimize the impurity. So we do not want to have this one because this one doesn't tell you how important is that particular features for your data set. Okay, so we talk about the entropy before and after. So this is before and this is after. So when I show you this one, basically we have 3 parts of entropy. Let me erase this one first. Okay, the first entropy is this one. This is 0.096, and the entropy for this one is 0. Entropy for this one is 0.96. Okay, so in order for us to compute the total entropy, so we need to have a weightage. So the weightage for this one is 5 divided by the number of elements we have will be 14. Okay, so times with 996, and then plus. Okay, this is 4 over 14. Okay, 4 because we only have 4 items here, and times 0, and then plus we have 5 also divided by 14 times 0.96. So this is the total entropy for that. So this is what we call the weightage. This is the weightage. So when we go back to the formula that we have just now, so this is the weightage that we are looking at. So for each of the partition, we will compute the weightage and also the entropy of that particular partition, and we sum up all of them. So the info gain can be computed by subtracting the entropy after splitting from the entropy before you split the data. Let me give you one example here. So we go back to the same example shown previously. So this one is the entropy for your data set here. So basically, the initial entropy here will be what we say. Okay, your initial basically this one. But how do you get this number? This one is basically, let me write down here. This is your initial. This one should be minus, and then how many no? 1, 2, 3, 4, 5. So 5 over 14 log 2, 5 over 14. Okay, and then we plus again the 9 over 14 log 2, 9 over 14. So this is the entropy before you split, because they are grouped into one grouping, right? So you compute all of them. So the initial will be this one. But after you splitting using the outlook here, then we have the sunny entropy, the overcast, and also the rain. So to total up particular partition entropy, so we use the 5 over 14 because we have 5 here, and then 4 over 14. The entropy here is 0, and this is 5 over 14. So we have this total of entropy, and you split them using outlook here. So before splitting, we have this, and after splitting, we have these three groups. So we just take this 0.94 minus this, and we get this. So this is the amount, what we call the information gain, how much improvement that we can provide to the data when we split them into few partitions based on the value of the features. So our objective is to maximize this, maximize the IG, and minimize the entropy for the after splitting. So always remember that if your IG is higher, it means the feature is good to be used to split your data. So we pick the one that will give you the highest information gain. Okay, this is another example. Okay, this for example, we could use the count here or the total here to split your data. Okay? For example, like this, before we split the data, your entropy will be this one. So basically, we have 5 over 5. So this one is the value is 1. Okay? Because remember that if we have 50% belong to another class, 50% belong to another class, so the value is 1. And then, okay, let's suppose we given the count feature here, I want to split my data using the values that we have in count. So the line here indicate that we have grouping. So we have this first grouping because they follow the value of the count here. So if A, they belong to one grouping and so on. Okay, so you can compute the entropy of the splitting using the count here. So basically we use the weightage. So we have 10 data here. So this is only 2. So the weightage is 2 over 10. And we have 2 belong to the same class. Then we have 3 here. And then we have 2 belong to no and belong to yes. So we have these values. And then we also have 3, but all of them belong to yes. And then this is yes, no. So half belong to us, yes, and half belong to us. Okay, so that's how you compute uh, compute this one. And then if you want to find the IG, so you just minus 1 from here. So if I use different pen, so basically this is 0. This is 0 because they belong to the same label. And this one is, can just say this is 1 because 50% of them belong to um, the other class. And this one you need to compute this one. So the system or the decision tree will also compute the IG for this and for all the feature that they have. So they will be one that give you the highest information gain. So that's why they call it um, recursive computation of entropy, and at the same time also they use recursive splitting. So after you split, use this one, you may use this one to split further until you reach the stopping condition. Okay, so that's what happened in decision tree, how they decide to split the data. They use the IG to decide which feature and what value to be used to split the data. Okay? So how do we apply this one in a real world application? So in this one, we are looking at the loan, identifying risky bank loan. Okay, so we have 5 parts here. The first one is we collect data. So we collect, and the second one is preparing the data and then training the model, and then how do we evaluate them, and then how do we are the other steps that can be done in order to improve your model performance. So we will be getting the data from the UCI machine learning data repository. They represent loan obtained from a credit agency in Germany. So this is how we read the file .csv. And then we also mention here the string as factor equal to true, meaning that all the factor will be maintained here. Okay, all the character will be maintained as factor or labels. So if you have a character, then they will be maintained as, and then this is how we show the structure of your credit data here. So the label that we are looking here is this one. So we can use the value any of these features to split your data. But they will do it very fast, so they will pick the best one. So label that we want to look at this is this one. So when they split the data, they will look at feature that can split. Most of them belong to no, and most of them belong to yes in different mode. Okay. So this is just to look at the what data we have. So we can look at the checking balance. So how many of them less than 0 Dutch money or greater than 200 Dutch money or between 1 to 200 Dutch money or unknown. We can also use the can could also check the saving balance. Could also look at the summary of the loan duration. So minimum and maximum and median mean. So this is the amount of loan. So maximum 18, minimum is 250. Okay. And we could also look at the proportion of the classes that we have. So this is for the default. Likely to default means they do not pay. Okay. So likely to default means 30% of people who apply loan will likely to default. Okay. So based on the history of the previous customer, they will try to model using the decision tree. So before we can train our model, we need to split them into training and testing. So over here, we use the sampling method. So from 1000, I will only pick 900 of them. So if I look at the value, so this is the raw ID that I get. So 900 of them. So meaning that 90% will be used for training. I put in the training sample. And the rest, 10% will be put in the test. Okay. So how do I divide the data into training and testing? So I will get all the ID for one that I sample just now and put in the credit train. Okay, and the remaining is minus, so meaning that all those not including in the train sample will be included in the credit test. So if we look at the proportion of the training and also the testing, we still maintain 70-30%. So that means our sampling that here is good enough. Okay. So now, once we split the data into training and testing, so we can install this package C5.0. So this is the name for decision tree, and then we upload the C0. Okay. So how do we create the model, or how do we train the model? So this is the model that will be produced. We'll call this function called C5.0. We'll give them the training data set and also the class. And then trials one, meaning that I will only build one tree. So once I train them, I will get this model, okay, and I will perform prediction based on the test data that I have, and the type of prediction will be class, no and yes. So how do we perform this one? Okay, so I will call the function C5.0. I will provide them with the credit and data set, except the default class, which is the last column indicated whether they're likely to default or not default. So I will remove that one. And next one, the parameter require the class label here. Okay, so let me remind you again here. Okay, remember that, okay, we have 17 variables here. So we'll give all of these to be as the data set, not that one, that one. We have all this 17, and that one, sorry. So all of this 17 feature. But I will not include this one in the training. So this one will put a separate column in the calling. So if I go back to here, so this is the train and also the class. So I will provide the training data and also the class here. So once I get the model, once I train them, so I have this model, I will take that particular model and then I will do the prediction. So this is the model I have. I will provide them with the test, and then the result will be here. So how do I extract this one? I will get this one, this value, and I will compare with the actual test label that we have. I'm using the cross table, and this is the value that are correctly classified. This is the value that is not correctly, so I'll use different color. So this one is wrong. Incorrect classification. This is okay. Okay, so the accuracy will be around this 27, so around 73% accuracy, because we have 17 error divided by 100. So this is the error that I have. Okay. This is for the testing, but what are the decision tree that we have? So we can use the summary here to show what are the rules that we can see from the decision tree. So here the decision tree says that if your checking balance is greater than 200 Dutch money, then you are not likely to default. But if your checking balance is less than zero, or in between 1 and 200 Dutch money, and your credit history is perfect, very good, so you are likely to default. So this one tell you this is correctly classified, this is incorrectly classified. So if we convert this one into sentence, so this is the sentence that we have. So if the checking account is unknown or greater than 200 Dutch money, then classify as not likely to default. So this one, if the checking account is this one or unknown, then not likely to default. Otherwise, if the checking balance is less than zero or between 1 and 200 Dutch money, and the credit history is perfect or very good, then classify as likely to default. So likely to not pay the loan on this decision tree. So the good thing about decision tree is that you can learn what are the conditions that being set by the model to decide whether they belong to positive or negative class. Okay, so how do we improve them? Because we could have one tree, if we combine them with another tree, become random forest tree. Okay, so we could improve them by having or by combining a number of weak performing learners or trees. Okay, so we could do the same here. So what happened here that we could add this parameter trials, meaning that we will build or model 10 using 10 decision tree. So if we repeat the whole thing, we perform the prediction here using this multiple trees, then we plot them. So we'll have the error here, which is error is 18%. So this is your error, and your accuracy will be 82%. So by having multiple trees, you could have better accuracy. Okay. Okay. So the main important idea is that you need to be able to compute the entropy and also how to compute the information gain. So the aim is we want to maximize information gain by minimizing the entropy of the data after you split them. Okay. So always remember that when we use that particular features and value of that particular features, we want to split the data in such a way that it will maximize your value for the IG. Okay, so this one is quite straightforward, but you need to do a lot of practice on the entropy and also the IG, like how to compute them. Okay, so I'll prepare assignment for you for that one. Any question? Any question? No question? Okay, let me share the attendance sheet again. Just in case you have not scanned in, let me know if you are able to scan in. Okay, thank you, Ahmad Haris. Okay, so my plan is next week we will have our midterm, right, on the 19th. So you will have your semester break during the after 2 weeks. So I will post the assignment, starting to post the assignment after your midterm. But if you will post the assignment earlier and also the practical earlier, so that you have more time to understand and have more time to deal. Okay. Any question? No. So tomorrow we will not have any tutorial. So next week we will meet face to face on Thursday. Okay.
I can't scan after free my number in the chat.
You cannot scan. Let me assist you.
Me also, Dr. Hariharan.
You type your ID in.
Yeah, already, Doctor, already.
Okay. Fahri. Okay, you okay? Who else? Ravindra.
Doctor, do we need to bring any laptop for the midterm?
No. All will be calculation. Will be no. You don't need to do any practical. All calculation. So you study all the calculation. So we have 61. Missing 2 or 3. Okay, so no tutorial next week.